we're going to explain how to check your module Classpath for missing or conflicting dependencies. This is crucial for ensuring your Java application runs smoothly. Problems often arise from missing libraries, dependencies your code needs but can't find, or conflicting versions of the same library, different parts of your application relying on incompatible versions. Let's explore how to identify these issues using both command line tools and IDE features. 1. Understanding the module. Classpath. Your module Classpath is a list of directories and jar files where the Java Virtual Machine, JVM, looks for classes and resources needed by your modules. If a required class isn't found on this path, you get a class not found exception. Conflicts occur when the JVM finds multiple versions of the same class, leading to unpredictable behavior or runtime errors. 2. Using the Java compiler, command line. The Java compiler, part of the JDK, can help detect some issues. When compiling your code with Javac, pay close attention to error messages. Errors like cannot find symbol often indicate missing dependencies. The compiler might not always catch version conflicts though, as it only focuses on compilation, not runtime behavior. To effectively use the Javac compiler, you would typically use the Classpath or CP flag to specify the paths to your dependencies. For example, Javac, CP, path/to/library1.jar, path/to/library2.jar, myMainClass.java. Incorrectly setting this class path is a common source of problems. 3. Inspecting build tools output, Maven, Gradle. If you're using build tools like Maven or Gradle, their output during the build process is invaluable. Maven's MVN dependency tree command provides a detailed dependency tree, showing all the libraries your project uses, including their versions. Any conflicting versions, for example, 2 different versions of the same library, will be clearly visible in this tree. Similarly, Gradle's dependency resolution mechanism will usually output warnings or errors regarding dependency conflicts. Carefully examine the logs from your build tool for any warnings or errors related to dependencies. 4. Using your IDE's tools. Most integrated development environments, IDEs, such as IntelliJ IDEA, Eclipse, and NetBeans, provide excellent tools for managing dependencies. They usually offer dependency viewers, which show the dependencies for each module in your project, highlighting any conflicts. Many also offer automatic dependency resolution and conflict detection features. Explore your IDE's documentation to learn how to use these features effectively. Often, a simple visual inspection within the IDE's project structure view can quickly reveal missing dependencies or jar files. 5. Runtime error analysis. If you encounter class not found exception or no class defound error at runtime, your application is unable to find necessary classes. Analyze the stack trace of these exceptions carefully. They usually pinpoint the missing class and, indirectly, the missing dependency causing the problem. Tools like a debugger can be useful to trace the execution flow and isolate the exact point where the error occurs. In summary, checking for missing or conflicting dependencies involves a combination of careful compilation, utilization of build tool outputs, leveraging your IDE's features, and thoroughly analyzing runtime errors. By systematically checking these aspects, you can effectively identify and resolve dependency issues, leading to more stable and reliable Java applications.